This is Juan Soto, your host, live with the Access User Groups with SQL Server from AccessUserGroups.org. If this is the first time you're joining us, welcome. Love to have you. We meet every second Tuesday of the month, and this month we have a very special guest. Her name is Kim Young. She's been working with SQL Server since version 4.0, Microsoft Access 2.0. I know of Kim for many years now. She's very passionate about Microsoft Access. And by the way, if you hear some background noise, it's because I am live from the Caribbean, and it's raining outside right now. So, so much for that. Kim has been involved with Access User Groups for quite some time, Chicago Access User Groups being one of them. She also has presented at Suburban groups in Chicago. She's passionate about Access with SQL Server. I am glad we have her tonight.
Thank you. Hello, everyone. Thank you for spending an evening with me. We're going to have very few slides. There are only 3, and we're going to get into the code. I would like to sort of frame up what we're going to talk about tonight, and I'm not advocating that you have to write code the way I like to write code. What I'd like to do is help you understand, if you're not familiar with SQL Server system tables and how you can use Access to create better code faster. And I'm going to show you how it works and what the concepts are, and I'm going to walk you through it. So first, if we think about technology, back in 1993, 27 years ago, the goal has always been to improve the quality of the product we produce. And at this stage of programming and technology and where we're at, a lot of what we do is very repetitive. We do it over and over and over again. We have to get data. We have to put it on a form. We have to validate it. We have to check it. We have to respond to things that users do. And if we can create code quickly that works all the time and is consistent, we achieve a lot of things. Anyone who comes to work on our application, once they understand the pattern that we use to build our application, will quickly be up to speed. And you don't have to worry about making typos and all sorts of other things. So we'll see that. And I am a graduate of Suburban University. And when I was going to school there, 60% of our grade came from documentation and code quality. It had nothing to do with whether or not you produced the right output. It had to do with the quality of your code, how well you wrote comments, what sort of documentation you did. This is essential. It makes it so much easier for anyone to work on our applications if we do this. So let's get started, and we'll look at, actually, I'm going to show you right up front what you're going to be able to do conceptually, what you're going to understand by the time we finish. So I have a simple empty database here from Access. I have one linked query from SQL Server AdventureWorks, and then a query that I have here that reads that data. And we're going to get right into the code. I'm going to show you what you're going to get. So if you're wondering, before I get started, I usually get a lot of questions. What's happening over here in my Code Explorer window, because it doesn't look like what you normally see in Access.
So, Kim, I don't know if I'm the only one, but I see a blank screen here. Better. Now I see the Visual Basic window.
Okay, great. So let me step back since we had some difficulty here. So what we have is a simple Access database, one linked query to SQL Server, and a query that I use within the application. So when we look at this code, what you see on my left-hand side is I use a tool from called rubberduckvba.com. It's free of charge and open source, and it's amazing. It makes working in the editor in Access so much better. So you can go to rubberduckvba.com and learn about this. I love it. I think, Juan, you use it as well. It's open source, and I have so much respect for people who are willing to do work and share it for free. So I know that they will take a donation, and I suggest that if you use the tool, you contribute because you want to say thank you and help them support their website and any profits that they have left over for the charity. So it's an amazing tool. I suggest you use it. So let's look at what we're going to be able to do by the time we finish this. So we have code here in a class, which I automatically generated. I didn't type anything in. So what we can do now is we can actually run this code. So here's the code that I just produced by clicking that button. Copy and paste it in. This doesn't mean you have to write code that creates classes. You can also paste this code into a regular VBA module and use the parts the same way. And I'm going to show you that this code works by running this test. So I have created my class, I instantiated it, I've passed a variable in, and I'm now about to call SQL Server to get the data out. I'm now going to do the debug print function, which is built into my class. We can see at the bottom here that all of the data, in fact, is being returned and put in the correct variables. So this works. So how do we make this work? How does this all happen? So I'm going to take you to AdventureWorks on my server. Can everyone see the database window from SQL Server?
Yes.
Okay. So the first thing we have to do is we have within every SQL Server database a large number of system views, which are you find by clicking View System Views. Information schema, the ones that start with information schema, are what they refer to as the DMVs, the management views, and the ones that you see in here that start with DM are also those. There are many other views in here, though, like objects. All of this describes everything you have in the SQL Server database. You can utilize these, and there's a lot of write-ups being done. You can find them for performance tuning, helping you to understand where you have locks, what's happening on SQL Server. But very little, if anything, is ever talked about in terms of creating documentation or writing code from it. This inherits everything in every database you create in SQL Server is based off what's in model. Not master, but model. So when you put up a new server and you get a new model database, all the latest views, system views, it contains other things. This is also a place where you can put objects yourself that you want to make sure go into every database you create. So as you can see, I have some views here. I have a couple of tables, dimension tables, Roman numerals, error logging, other things that I want to make sure appear when I create a new database. Now, if you add to model after you have created the database, it does not go into any of the existing databases. It's a go forward concept only. The first thing we have to understand, if we're going to try to create code, we're going to write code to write code, which sounds kind of like a mouthful. The very first thing we need to understand is what are our basic data types, right? Because if we're getting data, we need to know whether it's an integer, is it a string field, is it decimal, is it required, can it be null, all of that. So we start by saying what are the types of data that we can have. So if we look at sys types here, this is a standard SQL listing of all of the data types, and we should be very familiar with them. What surprised me about AdventureWorks, and normally when I take over someone else's database and I haven't been the person who builds it from scratch, I go through a lot of these metadata views in order to just get an understanding of what's there overall without having to go click into every table and say, okay, now how many, what's my, do I have a trigger, is there an index? You can get all that information about a database from these views. However, when I was preparing this weekend to put the queries together to do the demo, my code didn't run, and I was like, oh my goodness, what is wrong here? How is this not working? And I have to do this demo in 2 days. So when I look at AdventureWorks, I have more data types. Because what they have actually done is created some custom data types. Account number, which is really a varchar 30 field, a flag, which is a bit field. So they put all these different data types in, which explain why my code didn't run, because I have to translate. We have to translate what SQL Server data type is to an Access data type. So how do we do that effectively? We have to understand what the data types are. So kind of a surprise. If I was acting as DBA on this project, I would not have agreed to doing this. Again, why do I have to create another data type that just says it's varchar 30? I mean, just say it's varchar 30 or nvarchar or whatever it is. So let's look at the query that I actually used to write that code. And I have used this query for a couple of decades now. It's pretty standard. And I join systables, which is in this list, with syscolumns, and then the data type. The problem is, because they used those other data types, my code wasn't going to run, because I had a new data type called flag. So I needed to create something, a function, which would return the data type that I actually want. If I do this, don't need this, because I created a function here to get the actual system type from SQL Server that we're used to working with. So if I look at this now and run the query, I go down to the location table, small int, nvarchar, money, decimal, date, time, integer. We understand all of those, right? We know what those are and we know how to work with them. So it's kind of a surprise. You learn something new every day, so that's good. So the query that I use, if we look at AdventureWorks, looks like this. It tells me an object ID. In this case, they call table ID. Everything in SQL Server has an object ID. You can't always count on that, though, to remain constant. You say, well, why is that? If you create and drop a view or a stored procedure, when you recreate it, it gets a new object ID. So you always need to look for things based on schema name, table name, schema name, column name, however that works. But what's really nice here is if I look at this pay history table, you see the columns in the order in which they appear in the table. What is their name? Is it required? Is it the primary key? What's the data type? How big is it? Can it be null? Other things like that. Let's just look at location. So here I see the location ID. It's the primary key. It's the first column. It's a small integer. So this allows me to know everything I need to know about my data to write the code that you saw in the window earlier. Another thing is you have a table called schemas to tell you what the schemas are. And you should be aware when you take over a database or when you do one, there's a lot of schemas here. There's 19 of them. What's interesting is 1 through 4 are always the same in every SQL database. They're set up that way. And if you notice now, schema ID jumps way up when we get down to these. So what's interesting is what's principal, right? So if I join up to principal, I can find out who is the owner of this. And it's good to know that this is a SQL user, this is a window user, this is a database role. It gives me a lot more information about that particular schema and who's going to have access. While it's not necessarily relevant to the code we're going to write, it does tell me that I only want to look for schemas between here and here, most likely, in the tables that I'm looking for, right? These others won't matter, so I can filter my query to only be the things I'm interested in. Now, this is the DMV because it's the information schema view of this. And when I look at it, there's some nice information here, but the thing I'm missing is that database role. I need to know who this is, so I still need to join it to the principal table to get the information that I'm looking for. The real point I want to make here is if you're going to utilize these views, there's a lot of them, you need to understand the data that's being returned to you and what it actually means. Because sometimes the description will make you think it's telling you one thing and actually it's telling you something different. So let's look at an example of that. And I can share this script so that you can all look at it in AdventureWorks. So catalog name is your database. It's called catalog name for whatever reason. And the views that we see that are not the DMV or the DM or the information schema views, those have been there since the beginning of time. I've used these since I worked with the first version of SQL Server back in, I'm not going to tell you when, but it was a long time ago. They're there and they work. There have been rumblings since 2008 that they might get deprecated or they're not going to use them anymore. They're not going to be present. They're still here and they still work. Now, I could rewrite all the code that I've already written to try to use information schema views, but until it's broke, I don't want to spend the time doing that. I have a lot invested in this already. So one of the things I always do, here's tables from information schema. The thing it doesn't give me natively is the object ID back. And sometimes you need that object ID to join to some other data that's not present either in information schema here or in one of the DMVs. The reason for that is these DMVs and the information schemas, the views that come out under information schema, come out over time. They weren't there out of the gate. Every release of SQL Server, there's a few more that get added, but everything you're looking for, you may not find in those. Let's look at columns, right? Because we used columns in mine. We saw that. So here they have columns, and this is good. Good stuff. Is it nullable? Is there a default? Lots of great information here, right? It's a wealth of information. You can also see that columns exist for views. What's the ordinal position? And I created this view. So let's take a moment to look at it because it doesn't come as part of. All right, I'll come back to that. The point is, in this view, I joined a number of tables. All right, sorry. So you can alias columns. You're aware of that because if we were to look at the department table, there is no column called department name. There's a column called name. I have 3 or 4 columns here, all called name. And that doesn't help me know one name from another name, right? So I need to alias them. What's nice about this is we can see here that my view contains the names I gave the columns as I aliased them, not their original names. It tells me all the same information, data type, can it be null, how is it used? So that's very helpful. Here's one that says, tell me by view what tables are being used. So if you have to change a table or you're looking to say, do I have it in other views? Where's this table in this view? You can search on any of these parameters and find what you're looking for. So this can be really helpful. I see here that I'm using a function in this view. I have a table. Unfortunately, they all say table name when in fact they may be things besides tables. Here, if I execute that view, there are 11 columns. There's this view here called Information Schema View Column Usage. So I thought when I first saw this, oh great, this will tell me what columns are being used from what tables I view. But if I only have 11 columns that I'm returning, how come I have 14 rows returned here? Because this view column usage, tells me about columns that I may have used in a join, but I didn't actually return them in the results set. That's how come I have 14. There are columns which I have joined on in the where clause, which I don't return to you, which is why they don't show up in 11. So using this, if I was trying to write my code and build code based on this view, I would have faulty columns coming back because they're not actually returned in the results. So when I say you need to understand what data is being returned to you by these, this is why, right? Because you're going to try to find, and in the end, I think there are really only 3 tables, 3 views that you need to do whatever it is you're going to do, and we'll get to that, but there are a lot here, and they may provide information to you. We look at routines from information schema, we get all of the routines. Now what's interesting is, it tells me this is a function, this is a stored procedure, this is a function. The problem with telling me it's a function is it doesn't tell me the type of function. Is it a scalar function? Is it a table value function? How does the function portion of this work? So I kind of want to know, because how I get data to write code, I need to understand whether this is a scalar function or a table value function. And I'll show you why. So look in this, there's a column down here. SQL data access modifies or reads. Doesn't mean that it actually does any modification. If you read the documentation, if you go to Microsoft Docs and you look at it, read means it possibly reads data from SQL. Not it does, but it could. It modifies. The function possibly modifies SQL data. It doesn't mean it actually does it. So for me, I don't really want to know you could do it. I want to know what you actually are doing. So a lot of these, it's always null if it's a stored procedure. This always returns false for functions. So if it's a stored procedure. So for me, there's a lot of information in here that doesn't help me write my code. It might help me for something else, but it doesn't help me for this. Now if I look at columns for those routines, all my stored procedures and functions, I have this view called routine columns, and I go, oh, okay, but I only get 2 things back. What is it telling me? It only tells me for table value functions, the columns that come back. It doesn't tell me for any stored procedure what's returned. It doesn't tell me if it's a scalar function, what's coming back, what's the column name. So again, interesting, but doesn't really help me achieve my goal here. You have to look in a thing called parameters. And parameters now tell you what's going to come back and forth from your functions and stored procedures. So this is pretty good. Ordinal position 0 is always what's being returned. The parameters out, and the values in parameter mode can be in, out, and in, out. Out means it came from a function, a scalar function. In means it's an input parameter, and if we have any in, out, here we have one in, out. In, out means it's identified as an output parameter, but when you call SQL Server stored procedures, you can provide a value on the way in to that output parameter. So you're going to pass in one value and potentially get back a different value. So that's how come when it's a stored procedure, it's called in-out. This tells me the parameter name, the type of parameter, how big is it, length, collision, lots of good information. But you have to look in the parameters table. That's where you find it. Here, it's just interesting. There's a lot of these views. One of the things this does is key column usage. So if I look at a particular item, I can find the primary key, and I can know that this primary key for this table contains these three elements, and they are in this particular order. Now, why do I care about columns in keys or indexes? From a performance perspective, SQL Server uses decides whether or not to use the index based on the order of those columns. So if what you had was entity ID and address type, but you didn't have address ID, it might choose not to use this index because it doesn't have the next item in the index. It might use it, but it might not. So you need to be aware of the order that you put those fields in indexes and in your keys. You want to have the greatest chance of success based on how you query the data. All right, so let's go back to, so I started a little list here. What do we need to know? So far, what I showed you, I only use sys tables and sys columns. Let's go back to Access and start to look at the code a little bit. So in order to do what I'm going to show you is you need to use the scripting library that's available. So if we look here, we can see it's the Microsoft scripting runtime, because we're going to write that text file that we saw here out of this process so that we can put it in any language. So this code writing application that I have, which I'm showing you only part of it here, I actually write code to use in .NET. I use it to put in Excel. I can use it anywhere in Office. I use it with different backends. It doesn't have to be SQL Server. You have metadata about your data in Access. You can go look at your sys objects and your system pages there. So I write out a text file rather than trying to create a module actually in Access, because maybe what I'm using is I'm not going to do it in Access. So if you've ever worked...
Hey, Kim, we got a question from an audience member, Kent. He wants to know, do you change the ordinal position using T-SQL, or do you have to do it manually?
You have to drop and recreate the index in the proper order. So I would script it out. So you can come here and, say you want to... Oh, I'm sorry. I'm not sure what my connection is. Okay. I may have to...
Well, I think you answered the question. Yeah, it has to be done in the right order.
Yeah, and you can script any index out and create it in order to, see what you have here. So...
All right. Please continue.
Okay. So I'm going to put something back in here. Seem to not be happy that that wasn't there. So what you can do then is you need to have the Windows scripting module in order to use the file system object and then to write out a text file. So these are my two objects. So let's look at how this actually works. And I have simplified some of what you're going to see here because we only have another maybe 40 minutes to talk about this. I actually drive this through table. It's not as hardwired up as some of what you're going to see here. So let's look at this. So the first thing I do is I create a query string, and I'm going to select from that query that we saw earlier where my table name is location. So I'm going to do that for the location. and I'm going to say, I'm going to write it out to a file by this name. And I have some constants which tell me where's my path, how do I want to do this. So in order to create the text file, you first have to create the file system object. So you do that here. And when you say create text file, my name, true, what true means is if the file is already sitting there, it will overwrite the file that's there. If you say false, it will append to the file that's there. There's tons of free stuff up on the web about understanding how to work with it. It's very powerful if you need to loop through folders and do other things, but you can do a lot of things with it that aren't quite as obvious here. Now there is an open, but you don't need to do the open. When you create the text file, it is open. So now I execute, set up my DB, and my query string. Basically, the code is going to, this is going to drive calling these little individual modules. Here, and look at the things that we have. So the first thing is I have to do my declarations. So back in the code, those were the variables at the top that were private. Typically, when you write those in other languages, they start with an underscore because they're the private module level items. In VBA, you can't start with an underscore or a numeric. You have to start with an alphanumeric character. So when I do this, we'll write them out. If I'm writing classes, I then put the constructor in. I initialize the variables. I do the CRUD calls to get stored procedures, one for the create, read, update, and delete. I'm going to show you just the one with the create because there were a lot of things in AdventureWorks that they don't have all the stored procedures that we're looking for. I then create that debug syntax that you can see when we did the test and it printed out that all the variables have been populated. I then build helpers for those which use the class, and we'll walk through that a little bit. And I put the properties, which are these gets and lets, which happen down here. When I look at my class, here's the let and the get. I always, most of the time in many languages, the developers will put them up at the top. That's because they offer the concept, those programming tools, of something called code folding, F-O-L-D-I-N-G. That's what clicking these open and close. So you can hide code that you don't want to see and not have to look at it. In VBA, we don't really have that choice. So scrolling up and down to a whole bunch of things that once I've created them, I almost never have to go back unless I'm doing a change to a data type. I stick them at the bottom, and then we put in a destructor, and we close the file. And I loop through and do that for every table in my application that I want to do this for. And I have some very large applications, and I don't know about all of you, but I have some that I wrote more than 20 years ago that people are still using, don't want to change, don't want it to be any different. I have one I brought Maria in, and she worked with me on it. The database has 294 tables, so we're just 6 tables shy of 300, and it has 1,298 stored procedures. I do not want to write all that code by hand. I had to figure out a way to do it differently. So first, let's look at how we start to write. So I created a record set here, right? We got a record set, and it got my data from SQL that we saw through my query. I move to the beginning of the record set. So I don't keep recreating the record set. I just move back to the beginning. I then am going to loop through. I create comments. And all you have to do to write is this write line. You don't have to do this for the blank space, but because I copy and paste these in, they're there sometimes. So this puts my nice code block header. I then, from the record set, get the column name and I move it. I get the data type and I move it. And I go to this. So I'm going to So here, I'm looking at the SQL Server data types, and these data types all get reported as an integer by me. I choose to use an integer for a bit. SQL Server offers you the ability to have a triple state fit field or Boolean. Yes, no, and null. And the reason I went to this was just because I didn't say yes doesn't mean the answer is no. If you ever get involved where people are having to fill out, answer questionnaires, take surveys, do things of that nature, when they have to report the results, they need to say that someone did not answer. In Access, if you use a yes/no field, you cannot have null, I did not answer. So I handle that in my Access applications myself. So typically I have 0, no, 1, yes, and 2 is I did not answer. And then I handle that on this in the stored procedure if I'm getting data back from Access to make it be null. So I obfuscate that way in order to handle that. If I look at integers, SQL Server, this is the size for an integer. In VBA, you need to be a long because you need to handle this size. So this is why we went through looking at the data types and trying to understand. I also need to know if I'm going to initialize this column, what is the initialized value supposed to be? .NET, SQL Server allow a lot of things to be null that VBA does not allow to be null. You can't have null. It won't accept that. So I have to know, because I'm working with VBA here, what value I should put in. This brings me to this this global variable double quote. So you will want to, if you're going to try to do this, is in your globals, you're going to want to have globals for indenting, how to do a double quote, because if you're creating strings of text that are already in quotes, double quotes, how do you pass double quotes to it? So I figure out single quote and double quote, and then I never have to think about it again. I just use that variable, and it works. Here's my double quote. So here's what a double quote looks like. Here's what a single quote looks like. Here's my indentation spacing, constants, things like that go into this module for me. So if I go back to where I was, which I'm sure Maria knows some way I can quickly jump back there, but I always just scroll back. So now I've determined the data type. So I write out a line that says I want to create a private M underscore name of the column and then with the data type. So if we go back to our class here, that's what we see. Private M underscore location ID as integer, as string, as currency, as double, as date. So the next thing I'm going to do is I create a class constructor. Every class in VBA has a class initialize and a terminate. In here, I might call this module that I'm going to create to initialize the variables. Public sub, column name, my table name, and init variables. The reason I want to do that is whoever's using my class might want to be able to do the initialization later. Again, for some reason, they're going to call me again, but they don't want to, close the class, destroy the class, and create a new class. They just want me to clear everything out so that you can do it again. So as you can see, this is really, once you know what you want your code to look like, you're just filling in the parts, and you loop through and produce what you need to produce. How I normally start this process is I actually create a module that looks the way I want the code to end up. And then I come to here and I start filling in the parts and working on whatever it is I need to work. Here, I have my function to actually do the read, right? And I know, because I know how I create my application, so I hardwired this up, that I always have for every table a stored procedure that is the table name, MySP, table name, select by ID. That means I'm going to get one row back and it's all the columns. I have one called update, insert, and delete. I always know what they're called because I always make them that way, and I always have them. Now, I may have other stored procedures that I want to get back in here, and we can talk about how we get stored procedure information in a minute. I create my command object. First, I do declarations, so I declare things. I create a command object. I have my comments in here. I have add parameters. Let's go look at what that code looks like. So when I look here, anybody who comes to work on my code or work with me will see that I always have this structure, and they know where to find whatever it is they're looking for. And I don't have to keep doing it. Now, one of the things you could put in here that I haven't done, but I'm probably going to add to it, is put my line numbers in, right? Because then I don't have to type them in. I just implement them when I generate them. My parameters happen here. Now, I use these line labels because sometimes there's a lot of comments, and I'm trying to get to a particular point or thing, and if I know what they're called, I can just search and jump to them. Here's where all my parameters get put on to the command object. Right? So the first one is always the return value that you're going to get back from the stored procedure. You want then to add the input parameter. You then want to create the record set. You want to open it up. And because I know I'm only getting one row back from the stored procedure, I can then move the values from the record set to my variables. And I didn't write this code. The code writer does this for me. And I then return the record set here. So this module produces and would return to them the record set if they wanted to use it. Now, I tend to like to work with SQL Server in a disconnected fashion. So I will get the record sets from these functions and pass them to the forms, who then use them. And we are not holding a connection open to SQL Server when we've done that. And if you'd like to in the future have a discussion about what it's like to work with disconnected record sets, I'm happy to come back and talk about that. I also put in here the command timeout. Now this is 30 seconds, but sometimes you need to extend that time limit. Maybe you have a really big process. Maybe you're adding 1,000 rows because you brought in a spreadsheet. Now you've manipulated it and you want to push that data up to SQL. This will allow you to extend that time before it terminates with an APO connection through the timeout. Here's the name of my stored procedure. I'm using my connection object, and what we see here is I have a check my connection. When I call this code, it checks the connection to say, is it open? Great, if it's open, use it. If it's not, open it and leave it open so that the next time I go to call, there's one open connection to SQL. I return the results. I always have a wrap it up. This is where you do the cleanup. You destroy your objects, you close the record set, you set it to nothing, and you set the command object to nothing, and you exit the function. And here's my error handling. I provide a debug print for every variable. It helps with testing. If I make a call, I can make sure that I pass a record in that I have set up in test that make sure that every field is populated, and I make sure that they all come back and have the right values, and then I know I've done everything correctly. I then create class helper. I call this class helper. So what this means is I could have a form that got my record set back, and it can use those M variables that I also have at the top, and it would move the data from the record set through the loop into these variables for them, and you don't have to type it up. Here, I'm looping through the record set, I'm moving fields back. This would move it from your form to your variable, however you wanted to work that, and then I provide a debug print function for them to print it as well. And here's all those properties at the bottom. Once I've created them, I never need to look at them really unless I'm changing a data type for some reason or a new one gets added. So I always put them at the bottom because I don't want to see them. So you go, oh my gosh, I use these record sets, and I got to have an insert, an update, a delete stored procedure. That's a lot. I don't really want to write all those. Well, you don't have to. You don't have to write them. There is code out there, which I will also share with you. Unfortunately, at the time, I didn't think enough to that I should save who wrote these. So there's a couple of things, right? Here is someone using the metadata, same as we are, provided this script, and I just put the location at the bottom. Okay. Sorry. If I execute this, here are all my parameters that I would find at the top of my stored procedure and their data type. So I could use this then to quickly make my stored procedure. There are other stored procedure tools out there which will actually write a stored procedure by name. And hopefully my connection is going to be good and we're going to be able to run this. I can also provide these to you. Unfortunately, I do not have the person that it came from to give them credit. This is code. Okay. Again, what are we doing? Somebody's going to that metadata and wrote a stored procedure that will create a stored procedure for every table. Now, this isn't exactly a glamorous stored procedure. Like, I wouldn't want to have this be my stored procedure. We can look at it here. So this is my code because I have a template. This is all that got produced out of that. So I have a stored procedure template that I always utilize when I create a stored procedure. So in it, I have some standard fields that come at the top. If you ever support a web app, you'll need the actual user logged in, which isn't the web app login that's going to call your stored procedure. You need to manage row versioning, correct, right, so that you know I'm updating the row I see here. I set this template up, and Maria's seen this. She's worked with me. I have standard stuff. I like to use these. Again, helps me find my way. Put your variables here. You do your temp tables, whatever they happen to be. Housekeeping. Put these in. Turn code. It has error handling. If an error is thrown by SQL, I capture it into a table. And this is ready to go, and I use this. So even though that code that would have been produced was only this, I can paste it in and add my one parameter in up here at the top, and I'm ready to go. And I have a fully functioning basic stored procedure. And I may need to be doing other logic where this, I think, is most helpful, because inserts or select is pretty easy. To me, this is the one that's always painful. Writing all this, right? That takes a lot of time. It's not fun. So if somebody helps, if by using that code I get this, I've saved myself a whole bunch of time. There are others, which I'm also happy to share, which creates a much better looking stored procedure than the one you're going to get from that first module. It has a lot more thought into it. So it's cleaning, it sets default values, it's setting up the defaults, it's got all these functions. I didn't put all this in AdventureWorks. It produces a much better looking stored procedure. And again, what's happening? Somebody's reading those system tables. That's how all of this is getting done. So all of this is being done because people understand, who are writing this, understand what's in those tables and views that we get early on. So while you don't have to write your code the way I write it, you don't have to format it. Think of all the things that you can do that are repetitive that you don't have to do. And I think I demonstrated when we created that text file how fast that happens. Imagine if you had 294 tables and it took 2 minutes to write all that code. Imagine how long it would take you to write that command object over and over and over again, even if you pasted it in, and then you were manipulating the parameters or changing the name. that still takes you a lot of time. So the one thing, we saw a lot of views, stored procedures, for looking at things. I actually prefer to use only a few. And I didn't start with these. I do three things. First of all, I have a view here that gets everything out of sys objects, primary key constraints, foreign constraints. This gives me an overview into the database. I may not write code for it, but I may want to look at it for some reason. And I actually store this in a table. When did I first see this object? When was the last time I saw this object? Did I run the ORM on it? There are other things which go in it. So let's see. So I use sysobjects. What's interesting is you can't say whereas MS shift is false because you want only your stuff. Because what's really funny is there are objects which I have created. This is an object that I created. It's a user-defined table type. And we don't have time to get into this tonight, but what that does is the user-defined table type can be used in a stored procedure to pass a well-formatted array of data. In the past, you either had to create strings and parse them and do other things. This actually allows you to pass a well-formatted array of data. So if you had 100 rows, you don't have to make 100 separate calls to do the insert. You can pass it. Now, I haven't used a user-defined table type in Access yet. I know we use them in .NET, and since ADO is ADO, we should be able to. There is an input parameter type called user type, and if you do dot structure, Access doesn't give you the dot structured part, but it allows you to take it and doesn't give you a compile error. So I hope to get around to testing this soon to see if you can use this with Access. Because when you connect Access and you do an update and you've got 20 rows, it's doing each row one at a time. Whether you're aware that that's what's happening or not, that's what's happening. When you do, and what is SQL good for? SQL is really good at bulk processing, when you can work with data in what's called a data set, a set of data, rather than, and the famous phrase is always row by agonizing row. Do one row, then do the next row, then do the next row. SQL is not good at that. Oracle's really good at row by row. SQL is not. SQL is exceptional, though, when it comes to using sets of data that you're working on, a whole bunch of rows at one time. SQL does that really, really well. And you may not know this either, but when you do an update in SQL, it actually does a delete and an insert. There is no such thing as it just writing to the row that's there. It gets deleted and inserted. And if you ever work with triggers and you're trying to capture the changes, you'll look at the inserted and the deleted row to determine if the column, in fact, got changed. I know that's been we kind of whizzed through a lot of things here. So my object would show up as is Microsoft shift is true, but it's not true. I made it. So you can't always trust what comes back in that value. And what's interesting is my object name doesn't start with TT underscore or end with this weird number. So you have to parse it to find it. So what we didn't really have a lot of time to get into is, and you can join columns. Here, I join the columns. I just don't want the system tables or internal tables. When does columns work? Columns, these are the things that will return a column. Notice stored procedures not in here, so what's coming out of your stored procedures, there's no good way to find that. If you look up the documentation about it, it was last updated on 11/21/2017, but there is also a table type that I just spoke about, the table types. those columns are returned as well, but it's not actually in the documentation, and that documentation comes up under SQL Server 2019, but the last time it was updated was in 2017. So you have to spend a little time and get familiar with this. So how do I find out? So why did I choose objects instead of like tables? Because for me, objects gives me everything all the time, except for these two things that I've asked it not to give me. So if there's something newer that I haven't thought of in that database, it's going to come onto my radar if I didn't build the database and I'm not aware of what's there. I like to get everything and then filter it down to what I actually want. So if you look at this last one, this is the parameters. So it'll tell me the parameters that go in or out. So what's nice about this now is it tells me it's a scalar function. So a scalar function will never have an output column. What it returns to you is always parameter ID 0, and it never gives you a parameter name because there is no parameter name, right? When you create a function, you populate something, you say return, and it goes back, whatever it is. It does know the data type, but it doesn't have a name. I know that the column 1 here is the parm that I pass in, and this is what I get back for scalar function. For my table value function, I know the parameter that goes in, but I don't know what comes out, right? That's what I got in that parameters that we looked at earlier. We looked at the other function where that was. But here, if I look at my stored procedure, I can see my parameters. Here's everything for the stored procedure. Here's the parameter name that goes in. Here's the parameter ID that comes, the order of the parameters. But you have to remember that the first one, when you create a command object in EDO, has to be the return value that you get from SQL Server. The number, if it doesn't come back with a 0, it means the stored procedure had an error because you've set that. So how do we find out what a stored procedure returns? There's really no good answer for this. So there's a system function, describe first results. Here's what comes out of this stored procedure, but I have to execute this. So it can't be in my query. I have to somehow persist it into some sort of structure in order to find out what these are. But there's a couple of shortcomings with this. If you anywhere in your stored procedure have used the temp table, this won't work. If you return more than one result set, this only gets you the first one. So it is possible in SQL to return 4 or 5 different result sets out of a single call to one stored procedure. So you're only going to get one. It depends how sophisticated your database is. But what we have here is a structure. So here's a temp table that you can create. Someone kindly had that up on the internet somewhere. I insert when I execute into this temp table, and then I can select from it. So that result set is right here. So you'd have to persist this. So I do something a little kludgy. I will admit it's not super elegant. In most of my stored procedures that don't return data from just one row or one table, I will execute that stored procedure and have it write to a table in SQL and create a table. So I'll insert into, and the reason I do that is then I can take the benefit of having it be a table. I put it in a particular schema so I know it's really not a data table. And then I can link to it in Access and use it to lay out my form and then remove the link. But I have a definition that then means the output of that stored procedure looks like my tables and with my columns coming back the same way because I made it a table. Makes it a lot easier when writing the code to do that. So I really only need 3 things. I need sys objects, sys columns, and then I need to have the parameters so that I know the parameters that go in and out of a stored procedure. And then I can continue to write code for every one of those, the same as I did and demonstrated to you earlier. Okay, so thank you for coming. You can reach out to me here if you have any questions. I'll get Juan those scripts and he'll be able to post them up there so you can look at them yourself. You can reach out to me on LinkedIn. I'm happy to accept anybody who wants to connect with me and reach me here. And I'm happy to try to help you, point you in the right direction to the right view you want, or help you answer questions or point you in the right direction. So thank you very much for your time today.
All right, so guys, if I want you to walk away with one thing, one idea, and that is there are two ways to program access. You can use link tables and bound fields, or you can go with this method, which is unbound fields. And the problem with unbound fields is it requires a ton of code to do CRUD, right? Updates, deletes, inserts. But with Kim's approach, that's almost automated. You can then take advantage of all kinds of situations, especially when you have low internet speeds. And you can't connect with SQL Server on a constant basis. So keep in mind this technology approach that Kim has talked about and automating the store procedures that you need to do CRUD with disconnected record sets. So thank you very much, Kim. It was very informative. I, for one, have never seen this approach, so I learned a lot today. And I'd like to thank everyone who, you bet. I'd like to thank everyone who came in tonight from around the world. And we will be back in June. Normally I take the summer off, June and July, but since everybody's at home now, you guys have no excuse but to show up. June, July, so we are going right through the summer. No summer break this time for anybody. So we'll be back here in June, second week of June, second Tuesday of June. Again, thank you very much for being here. This has been Juan Soto, and please follow me on Twitter at jsoto22, LinkedIn at linkedin.com/n/Juan Soto. And by the way, I have a new blog post, and Microsoft has recognized our COVID supplies database, free COVID supplies database on the Microsoft Access blog. So I invite you guys to check out my blog at AccessUserGroups.org. Learn more news about that. And if you haven't downloaded yet our COVID supplies database, please do so. And we will be back here in June. So thank you very much, everyone. Have a great night, and we'll talk to you then. Bye, Kim.
Bye. Thank you.